All right. Radicals cannot be left in denominators. So when we are simplifying radicals, you have to remember this. Cannot be left in denominators. Or in the denominator, in the bottom of the fraction. All right? That is important to know. The reason why, I have a lengthy explanation, but we can, I can always answer that later. So so when you do have a radical in the denominator, what you have to do is you have to rationalize. That is a process, all right? Rationalizing the denominator is a process. And it says here, simplify so that radicals are not in the denominator, all right? So the process to rationalize the denominator is you multiply the top and bottom by the radical in the denominator, okay? So we're going to do 4 examples, and this will work for all problems that have radicals in the denominators. All right? Well, since this is a fraction inside a radical, using the property, I can pull it apart. Square root of 1 over square root of 2. Well, simplify. Well, square root of 1 is 1, so I got 1 over radical 2. Now, square root of 2 cannot be simplified. But I cannot leave my answer like this because you notice I have a radical that is in the denominator of this fraction. Right? So what I need to do is I need to rationalize it. In other words, rewrite this so where the equality is still the same, but the radical is no longer in the denominator. Okay? So the process is you multiply the top and bottom by the radical. So the square root of 2, so that means I'll multiply the top and bottom by the square root of 2. So 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4. Well, we know square root of 4 becomes 2. And there I go. So even though it's the same thing as saying 1 over radical 2, they are the same, but you notice this one has the radical up top, and this one has a radical in the denominator, right? So you need to know how to rationalize the denominators. All right, number 2, so we pull this apart, is radical 2 over radical 5. Okay, none of them can be simplified. So now I have to rationalize, because rationalize means I cannot have a radical, I cannot have a radical in the denominator, so I must rationalize it. So I must multiply the top and bottom by that radical. So it'll be radical 5, or square root of 5. Well, since they're both square roots, and I'm multiplying, I can multiply the two numbers, so that's square root of 10 over square root of 25. And now I simplify again. Well, radical 10, or square root of 10, cannot be simplified, so we just leave it. And square root of 25 is just 5. And there you go. I cannot take 10 and divide it by 5, because this is a square root of 10, wherever that number is, then I can divide it by 5. All right, so do not take this a step further, which some people will, which is a common mistake, is you cannot take a square root of 10 and you divide it by 5. Both of them must be in the same radical. This is a radical, this is it, so therefore I cannot do anything with these two parts. Number 3. All right, so this becomes square root of 1 over square root of 3. Square root of 1 is 1. All right, so I'll multiply the top and bottom by whatever the radical is in the bottom. In this case, this is radical 3 or square root of 3. 1 times square root of 3 is square root of 3. Bottom is square root of 9 equals, so therefore it'll be square root of 3 over 3. Now, I did this the long way. Well, somewhat a long way, because if you notice, I had a square root of 2 in the bottom, and when I'm finished rationalizing the denominator, I just have 2. This one I had a square root of 5, but when I rationalize, I get 5. Here I have a square root of 3, but when I rationalize, I get 3. All right, so you should see a pattern here. All right, so I'll leave it like this. All right, hit the pause button, finish this problem by the little thing I just showed you. All right, so go ahead and hit pause, and then do the problem, and when you're done, hit play, and then you'll see if you're correct. All right, so let's see if you're correct. So you multiply the top and bottom by square root of 7. Since these are both in the same radicals, I can go ahead and multiply, so that's square root of 21. That does not simplify, so we leave it, and this becomes 7. And there's your answer. Right? If you have any other questions, please post them, or see me in class, or send me email, whatever, and I'll be glad to answer any questions.